The Sun is the star that holds our solar system together, a vast sphere of glowing, shifting plasma that has shaped the history of Earth and every world around it. It gives us light, warmth, and energy. Without the Sun, our planet would be a frozen, airless rock drifting through darkness. For as long as humans have existed, the Sun has inspired curiosity, worship, and wonder. Ancient civilizations recognized it as the giver of warmth and the bringer of daylight, often treating it as a god or a symbol of life. Farmers used its rising and setting to track seasons and guide planting. Early astronomers followed its movement across the sky, discovering patterns that helped develop the first calendars. Long before we understood the Sun scientifically, we understood instinctively how essential it was. Across every culture, the Sun has shaped stories, rituals, and the rhythm of daily life, a constant companion in the sky, both familiar and mysterious. The Sun was born about 4.6 billion years ago from a collapsing cloud of gas and dust. As this cloud fell inward under its own gravity, it began to spin and flatten into a disk. Most of the material gathered at the center, becoming hotter and denser until the pressure was high enough to ignite nuclear fusion. That moment marked the birth of our Sun, a new star shining in a young cosmic neighborhood. The Sun is made mostly of hydrogen, with helium being the next major ingredient. Deep inside the core, hydrogen atoms are squeezed together so intensely that they fuse into helium. This process releases enormous amounts of energy. It's this energy that eventually reaches us as sunlight, though the journey is incredibly slow. A photon created in the core can take thousands, even millions of years to fight its way outward through the dense inner layers of the Sun. Surrounding the core is the radiative zone, a region where energy moves outward, mainly through radiation. Farther out, the convective zone stirs and churns like a boiling pot. Hot material rises, cools near the surface, then sinks again. These constant motions shape the surface of the Sun into shifting patterns and bright, bubbling textures. The photosphere is what we see when we look at the Sun, the visible surface, even though the Sun has no solid surface at all. It is here that we see the Sun's ever-changing texture and the effects of magnetic forces pushing and pulling beneath the surface. Sunspots are among the most recognizable features on the Sun. They form when strong magnetic fields rise through the Sun's layers, blocking the normal flow of heat and creating temporary cooler patches that can be larger than Earth itself. Sunspots often form in pairs or clusters, and their numbers rise and fall in an 11-year cycle. They are closely tied to solar flares and storms, offering clues about upcoming periods of increased solar activity. The Sun's magnetic field plays a key role in shaping nearly everything we see on its surface. Unlike Earth's magnetic field, which is relatively stable, the Sun's magnetic field is constantly twisting and tangling as the Sun rotates. This builds enormous tension below the surface, which can suddenly snap and release in the form of solar flares and coronal mass ejections. The magnetic field also flips completely every 11 years, marking the peak of the solar cycle. This magnetic heartbeat drives sunspots, storms, and many of the Sun's most dramatic behaviors. The Sun does not rotate like a solid object. Its equator spins faster than its poles, completing a full rotation in about 25 days, while the polar regions can take more than 30. This uneven rotation stretches and distorts the Sun's magnetic field, contributing to the formation of sunspots and increasing the energy stored beneath the surface. The way the sun rotates is one of the main reasons its activity is so dynamic and unpredictable. Above the photosphere lies the chromosphere, a thin reddish layer that becomes visible during a solar eclipse. Beyond that is the corona, the sun's outer atmosphere. Strangely, the corona is far hotter than the surface below it, reaching temperatures of more than 1,000,000 degrees. Scientists are still working to understand how the corona becomes so hot. This superheated plasma expands outward as the solar wind. Eclipses offer one of the most dramatic ways to study the sun. During a total solar eclipse, the moon passes directly between Earth and the sun, perfectly blocking the bright photosphere for a few brief minutes. With the glare removed, the chromosphere and the pearly white corona become visible. Ancient cultures saw eclipses as mysterious and sometimes frightening events, but today they are rare scientific opportunities. Modern eclipses allow astronomers to observe the sun's outer atmosphere in detail, revealing the structure of magnetic fields, the origins of solar wind, and the changing shape of the corona over time. The sun is constantly active. Loops of magnetic energy rise and fall on its surface, carrying glowing arcs of plasma. Solar flares erupt with bursts of radiation, and sometimes the sun releases enormous clouds of charged particles called coronal mass ejections. When these storms reach Earth, they can create beautiful auroras, but they can also disturb satellites, radio signals, and power grids. Even though the sun seems calm from our perspective, it is a dynamic and ever-changing star. Its activity rises and falls in cycles that last about 11 years. During the peak of this cycle, sunspots, flares, and storms become far more common. Deep in the sun's core, fusion reactions produce tiny particles called neutrinos. These particles almost never interact with matter, passing straight through planets, buildings, and human bodies as though they weren't there. Billions of them travel through you every second. Neutrinos are important because they escape directly from the sun's core, something light cannot do. By detecting them on Earth, scientists can confirm that fusion is happening exactly as expected inside the sun, offering a rare glimpse into the regions where sunlight begins its long journey outward. To understand the sun more deeply, we have sent several spacecraft to study it up close. NASA's missions have monitored solar storms and tracked the sun's activity for decades, giving us a clearer view of space weather. The Solar Dynamics Observatory watches the sun around the clock, capturing high-resolution images of its surface and atmosphere. The Parker Solar Probe, launched in 2018, is now flying closer to the sun than any spacecraft in history, diving into the corona to measure heat, magnetic fields, and the origins of the solar wind. And ESA's Solar Orbiter is mapping the sun's poles for the first time. These missions, historic, active, and future, are helping us understand how our star works and how its energy shapes the entire solar system. The sun's activity also creates one of the most beautiful natural displays on Earth, the auroras. When charged particles from the sun travel along Earth's magnetic field and collide with atoms in our upper atmosphere, they release light in shimmering curtains of green, red, and violet. These glowing waves appear near the poles as the Aurora Borealis in the north and the Aurora Australis in the south. Auroras are living proof of the invisible connection between the sun and Earth, a reminder that our planet is constantly interacting with the stream of energy flowing outward from our star. The sun is essential for life on Earth, Its light fuels photosynthesis, which supports plants and the entire food chain. Its warmth keeps our oceans liquid and our climate stable enough for complex ecosystems to exist. The gentle push of sunlight drives weather patterns, powers the water cycle, and shapes the winds. Though it dominates our solar system, the Sun is actually an average-sized star, a G-type main sequence star, sometimes called a yellow dwarf. There are stars much larger, hotter, smaller, and cooler. But for us, this ordinary star is exactly what life needs. The Sun is now about halfway through its life. In roughly 5 billion years, it will run low on hydrogen fuel in its core. When that happens, the Sun will begin to swell into a red giant, growing so large that Mercury and Venus will be swallowed, and Earth will be scorched beyond recognition. After shedding its outer layers, the Sun will shrink into a dense, Earth-sized white dwarf, a dim hot ember slowly cooling over time. Even though that future is unimaginably distant, the Sun continues to evolve moment by moment. Every second, it converts millions of tons of hydrogen into helium, releasing enough energy to sustain life on our world. Every sunrise we see is the result of ancient photons finally reaching us after a long and difficult journey from the center of our star. The Sun is more than just the source of daylight. It is the engine of our solar system, the reason Earth is habitable, and a reminder of the vast cosmic forces that shape our existence. Understanding the Sun means understanding our past, our present, and the future of our world. Thank you for exploring with me. I'll see you in the next video.